We're going to take another look at domain and range given a graph. So the first thing let's look at is domain. That's all possible input values, which are x. So in the previous video on this, I showed you you're going to hold your ruler in such a way that it's always touching the x-axis because we're looking for all values of x. So if I hold my ruler like this, and I slide it left to right, notice it's always touching my x-axis. So I know I'm going to be getting my domain. So I'm going to start on the far left, and I'm going to move my ruler until it touches whatever that relation or function is. So my first place that it touches is right here. I'm going to see what's the value of x right there. Well, the value of x right there is -1, -2, -3, -4. So my first input happens when x is -4. So as I showed you before, I'm going to go ahead and I'm going to make just an x-axis up here at the top because that's going to help me remember how to write this in set builder and interval notation. So right here, I get x at -4. I'm going to assume that it can include it, so I'm going to close that in because there's no open circle there. So as I'm going here, I start getting multiple values for output, so that's going to help me answer that function question. But notice as I'm going here, I'm still touching the function. I'm touching it at two places for x. Here, everywhere here, there's two values. I mean, x is the same, I'm sorry, I'm saying this wrong. X is here and here the same value of x, but I'm getting two outputs, okay? But let's just stick to the domain. So I'm going to keep moving this way, and notice that I'm touching the ruler here as well as here. I'm touching the ruler here as well as here. That relation is touching the ruler everywhere until I get to this place right here, and that's the end of that relation. As I'm moving my ruler, I'm no longer touching the function on the edge that I was looking. So that's the end. So what would this be? 1, 2, 3, 4, 5. So that's where x is 5. It includes, and remember, this relation runs in between those 2 points. So that means that my x is all values, my domain or my input is all values between -4 and 5. -4 is less than 5. So I'm going to write it like that. And I'm going to say it can include those endpoints also. So that makes set builder notation easy. It's the set of x such that -4 is less than or equal to x is less than or equal to 5. Okay, so now what I want to do is I want to write this in interval notation. While looking at interval notation, where's my smallest value is at -4. It can include it, so remember that's my equal sign for interval notation. Oops, I meant to use the green pen because we're talking about domain. So that's -4, and then we go all the way to 5. So everything, every single number that exists between -4 and 5 can be our input for this function. So now let's look at our output values or our y. So again, we're going to hold our ruler such that it's always touching the y-axis. I always start at the lowest point. As I'm going along, I'm not touching that relation at all until I get right to here. And once I get right to there, that's my beginning of my y. So my y is beginning right here. What's the value of y right there? Well, the value of y right here is 0. So again, I'm going to go ahead and I'm going to do just the y-axis to help me examine. Pen stopped working there. To help examine my range. So as I'm going this way, I notice that my y begins right here. That's where y is 0. And I keep touching the function. I'm touching the function here and here. I'm touching the function in 2 places. Every time here, I'm touching the function many places, but all these places only have one value of y. And that value of y, I believe, is 4. 1, 2, 3, 4. That value of y is 4. Okay? So that's the top, that's the bottom, it includes it. And notice that this graph is connected everywhere in between. So it's connected everywhere in between. So I know I'm going to turn this sideways a little bit. My numbers are weird. I know my y is in between. 0 is less than 4, so I write my inequality like that. And it can equal the endpoints. So that means when I write set builder, I'm going to say the set of y such that 0 is less than or equal to y is less than or equal to 4. And then my interval notation is, well, what's my smallest value? My smallest value is 0. It includes it. And it goes all the way to 4. And it includes that also. So I kind of gave away the answer. Is this a function? And the answer is no. This is not a function. It failed that vertical line test. Well, let's see what that is. A function is a function if for a particular input we get only one output. So right here, if I just take where x is -2 right now, I have a point there and I have a point there. So this is going to give me some output and this is going to give me another output. I can only have one output for each input. So this is not a function. Let's look at one more. We're going to do 2 and 1 on this video. And this one's a slightly different one, and I want you to think about this when we do it and not just blindly go through the motions. So we're going to find the domain, all possible input values of x. So again, if I put my ruler like this means as I slide it from left to right, it's always touching that x-axis. And I just want to let you be aware that I'm only looking at this edge of the ruler when I'm talking about that. So if I start here, you might be inclined to say, well, I'm not touching the function. That would not be true. Because what does this arrow mean? This arrow means that our function continues everywhere to the left and everywhere to the right. So I'm just going to take another pen and I am going to extend this part of the graph to show that this is actually going everywhere that way and it goes forever that way, okay? So notice how that's what I have to think in my head, that these arrows are going forever either direction. So that means when I put my ruler here, do I begin at 10 or -10? Actually, no, I'm actually beginning before then. Where is before -10? Well, remember that this arrow goes forever to the left. So if I could go forever to the left, I would begin at -infinity. So my beginning would be -infinity. So as I'm sliding my ruler, it's continuously touching my x-axis, but it's also continuously touching that function. And I can take my ruler and slide it forever. I'm not stopping here because that arrow keeps going. So how far can this keep going? It can keep going forever. So forever is infinity. Okay? So if I were to draw, like I had you do in the previous graphs, I had you draw just your x-axis up there. And remember, what did we do? We started at -infinity and we ended at infinity, and it was everything here, right? So what's another way of saying everything? So it's every number, every single number that you could ever imagine saying. So that means all real numbers, all real numbers. Okay? So, set builder notation. The set of x such that x is the set of all real numbers. So that's how you do it in set builder notation. So interval, where's the smallest? The smallest starts at negative infinity. Can we ever reach negative infinity? No. We can get really close, but it keeps running away. And I keep going. I don't stop. I keep going. I keep going. I keep going. As I could point out here, I keep going. I keep going. I keep going until I get pretty close to infinity. So the interval notation is from negative infinity all the way to positive infinity. So let's talk about our range. Okay, so here we go. So our range, I'm going to hold my ruler so that it's always touching the y-axis, because that's where I look to find my y values. So as I'm going up, I'm going up, I'm going up. Don't get confused with your x-axis. That's not what we're looking at. We're looking at the function, and the function is right here. I only have one y value. Even though the line's this way, remember, everywhere along here, my y is the same exact value. So right here, that's the point 0, 1, 2, 3, 4. That's the point 0, 5. This here is the point 1, 2, 3, 4. That's the point 4, 5, right? Over here, that's the point negative 7, 5. So you notice about here, y is always 5. In fact, that is actually the line y equals 5 if we were to write the equation of the line. So I only have one point right here, and that's the point 5. So if I were going to do my number line, like I had you do in the previous one, for your y-axis, my answer would only be that one point right there. So how do I write that in set builder notation? Well, it's the set of y such that y is exactly 5. End of story. Interval notation? Well, the only point I have is 5. It can be exactly equal to 5. And yes, this is a function. It passes the vertical line test for each input. Like if I look at negative 7, I only get one output of 5. If I put in 0, I only get one output of 5. If I put in 4, I only get one output of 5. So yes, this is a function.